So I guess we could start with some, I guess, anonymous introductions.
Yeah, sure. Do do you want to start?
Yeah, so I guess I'm a CS student, senior, studying at college. I did a couple of internships before, and now I'm just sort of, prepping for new grad roles.
Great. So I'm actually a software engineer myself. I've been working for about 10 years, and I like to, always be coding, so that's why I'm doing this. All right.
Gotcha.
Cool. So I'm excited to chat with you this morning. Do you want to jump right into the technical questions?
Sure. I'm just gonna switch over to Python for this.
That's perfect. All right. So the problem that I'm going to give you is something that is one of my favorites. Um, I'm going to just write the problem statement here.
Sure.
So given the non-empty string and the dictionary of word, uh, please write a function that can determine if the string can be basically composed out of the words in the dictionary.
Right. So just to make sure that I understand this correctly, I'm given, say, some input string, and I'm given some dictionary, which has entries. So this is just a set, and I have to basically return, uh, the valid splitting, right? Or,
Um,
or return true or false if there is a valid splitting that works
Correct.
out.
Yeah.
Okay, so I'm pretty sure I have done this problem before. And what I think the approach ends up being is that this is a dynamic programming problem where you can actually, say, store at each index whether you can actually, say, have a space delimited set of words to that point. And what you basically end up having to do is going from index, say, 0 to n, and each time looking back and comparing, to figure out whether at some intermediate index you can form a word. You look at all previous places where you could form a word and then see if the substring formed from that point to your current index is also a word. And if it is, then, the index is set to true.
Right. So there's multiple ways that you can solve this. So I think what you're describing sounds like one possible way to do it. Can you
Yeah.
kind of like map this out in an example and walk me through the solution that you're thinking about?
Sure. So let's say that I had an example such as Facebook, and my words were, Facebook. Facebook. Let's pretend that it's a real word.
Yep.
What I'd basically have is an array, all set to false, of length 8, or I guess it's supposed to be 9 if it's n plus 1. That kind of edge case we can handle in actual code. And basically, I want to start from index 0 and check if, say, I guess it would be n plus 1, because I would end up saying that from index 0 to 1, is that substring a character? No, it isn't. I would try to backtrack all the way and see all other possible substrings, but there are no other substrings that could use previous values. So I move on, check 0 to 2. Is that a word? No, it isn't. You'll have the same logic repeat. 0, 3 still isn't. 0, 4. Finally, we get to face, right? We'll end up seeing that we can compare the substring, or we can see if the substring face is inside of our set. And when we find that it's true, we'll at this point have, true, false, 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 true, right, as our solution. Because
So I guess allow me to jump in here. This array of booleans, what does it represent? Is it one boolean in the dictionary?
It's basically a Boolean indicating whether you can do this. If S to end can be segmented into space-separated sequence of one or more dictionary words. There is, one small thing that we're doing and including an extra true at the very beginning, even though that's not really true, right? Like if you end up having an empty string, obviously you can't split your words this way. But the point of having the true at the very end is just so that when we want to compare the entire string and see if it's within our set, we want to do that in that case, right? Without having to include additional logic.
Right.
So if I were to continue, when I get to, say, book, where I would have just this, and I'd get false, 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 and then this is the last check where I check for Facebook. I would see that at position 0, 1, 2, 3, 4, there's a true, right? So what I'm going to do is say, okay, up to S of 4, the answer was true. Now, is S of 4 to my current end in the dictionary? If it is, then my S of, my solutions of end becomes true, right? And then I continue.
Right. Okay.
Yeah.
And
so at the very end, I should just be able to return solutions of n, where n is length of the input string, to determine if the entire question that we care about is true or false.
interesting. Yeah, I think that approach should work. One interesting question that comes to mind is, in this scenario, how do you deal with so you can split Facebook into face and book, but you might also be able to split it into just Facebook, right? Because that's also a word in your dictionary.
Right. So because we only care whether it can be, separated and not what the actual contents are, it doesn't really matter for us.
And if we were to make this more interesting, where, instead of doing Facebook like this, you have something where it's just, what would be an interesting example here? So
Let's
this
say,
doesn't match. Like if you had, for example,
yeah,
like
sure.
this.
So what would happen in that case is on line 25, our array, it would check the true value here, but then when it tries to check on line 29 if solutions of end is, S from 4 to end is in the dictionary, you'll actually get that it isn't, right? And so then we keep going back until we get to index 0. So now finally we'll check, is S of 0 to end in the dictionary? And here you'll see that that's Facebook, and so it'll be set to true.
Okay. Yeah. So yeah, I think that's definitely a great starting solution. You wanna kind of start writing maybe either code or the code for this? I think, as you say this, there might be an opportunity here to optimize things a little bit. But let's just start with first code.
Okay. So I'm just gonna define this as space separated, which is just gonna take a string S, and it's also gonna take a word dict, right? So I'm assuming here that a word dict is actually just a set or a map instead of a list, so that we have, on average, big O of 1 lookups. And then I have my, can separate is just going to be false for s, false for each of the indices in range n+1. And then we set can separate of 0 equal to true. So what we said we were going to do is have a forward that goes into the range of n+1. And we basically want to determine whether you can make a solution to this point, right?
Right.
And then the other thing we have is a separate inner loop, which is going to go from forward -1 until 0. And I guess just some context for this code with the -1, -1. It's basically saying start from the position behind forward, go until index 0, and go back by 1 each time. So it's just a reverse loop. Cool. So what we wanted to say is if can separate at backward, in that case, this is a possible place that you'd want to check and see if the thing that there's a new substring formed from this point. So if s of backward until forward in word dict, then we can pretty much break out, right, of the entire forward loop. So let's see, I can't really break fully, right? So we can fix that after. Let's just say that can separate forward in that case is equal to true. Then I guess you can have a small little check to stop, repeated looks. It's true, in that case we break. So there's definitely some problems with this already that I can notice. For one, we definitely want to start from position 1 instead of position 0, just because there is no string going from 0 to 0, right, or -1 to 0. That would be an error. And then another thing to account for might be, I was thinking if you just had, the final, say, Facebook where you have to compare to 0, right? Does that code actually run? I think after we made the 1 fix, it should. So the inner loop where we say if can separate on backward, that will run now guaranteed on every loop forward. Yeah, that looks to be okay. And then we'd want to return can separate of n. So the easiest thing to do would probably be to just run reason through a test case for this, because this does seem to be the translation of the idea we had in the actual code. Let's go again with Facebook, and then we have Facebook, and then Facebook. Or I guess more interesting, we just use the, incorrect book spelling. So starting off, our n is going to be set to 8 based on the length of the string. There's an edge case we're not handling here of an empty string, but I think it's guaranteed that it's non-empty words, right? Yeah, it says given a non-empty string, so we don't really have to handle that in the actual code. So, right, I have n is 8. I make can separate end up being false times 9, and I set the initial can separate at 0 to true. So I start looking at f, and I say my backward is equal to 0, and can separate of 1 is still not true, so I don't break, and can separate of backward is true. I check if f is in the word dict. It isn't. The backward loop is now complete because the next value would be out of the range, and so forward moves to FA, right? Or not forward moves to FA. Forward moves to 2. So that now I'm looking at the substring FA. It should be the same logic, that goes through to say that FA is not in the string. The only thing that seems to change is that now I have multiple loops of backward. So the first time my backward is equal to 1. Is that what I would want? Yeah, it would, because then that means that my first substring is just A without the F. And then on the second loop, my backward is going to be 0, which is going to give me FA. And neither of those are in word dict. So one thing that seems to be, okay, never mind. I was going to say one thing that seemed like it was an issue is that it seems like I'm disregarding previous characters, but I only update can separated forward in the case that I can create in case I do have a solution from the backward string. So actually the A substring, I don't even look at that. I'd only look at FA, and then, so the next loop of forward, I look at FAC. Next loop of forward, I look at FACE.
Right.
And now I finally find my backward should be 0. My forward from the previous reasoning was 5. Yeah, that would be what I would want, and this seems to check out. Yeah, so I'm pretty confident that for the next loop through, this is going to run as intended as well, because I don't really see any strange, off by ones with the backward pointer. Is it okay if I actually run this as code?
Sure, yeah. Feel free to create. 1 second, please.
So we're just going to print space separated, S and word dict, and let's see what that gives us. I forgot it.
Yeah, I apologize for that. My little one was interested in coding. Yeah, so I was going to say, yeah, feel free to create some test case and let's see how this works.
Sure. Name word dict is not defined. Strange, did I not just define it right here? Misspelling? Misspelling. Okay, so this one gave me true as I'd want. Book should also give me true. Now if I try book without Facebook, this should return to me false. Yeah. So let's think of some better test cases. I have obviously the one where it can be split multiple times, where the final word is a valid string. I see here when it's, the last word isn't correct or isn't part of our solution, it returns false as intended. I could try and reverse that, so that maybe instead of base being the correct word, maybe the last word is correct and part of our word dict, and this should give false, and it does. We don't have to care about the none or empty string. So another thing maybe to look at is the edge case of a single string. See that we don't have any out of bounds with our array, so that's okay with FCT and book. This is returning false as intended, and when we only have A, this returns true as intended. So I think this is pretty okay, and this will be my final solution.
Yeah, that was great. I would like to try one more test case. What about the case where you have the word that, is almost repeated in the dictionary? So let me try something like, you have apple, and the other one is just, let's misspell apple this way. And you're trying to look for, just apple, for example. Let's run
Right.
this.
Sure, so this should return false, and we get that
Okay.
intended.
But now, what if you did, I'm trying to think of red case here. So instead of doing that, you want to see if it tries to match it greedily. So Apple, this should work, but this shouldn't work. Let's try that
Yeah, this should
together.
return false. We still get that because we're never going to hit that condition on line 46, right?
Right. And the last test then would be something like this. And that should return true. Right?
Right, because it's AAPL and then E. Cool. So that one also works out.
Great. Perfect. Can you speak to the kind of complexity of this solution?
Yeah. So if we just look at the loops, that ends up being n squared. There is an additional cost in terms of the subscripting. But I think when you think about the problem, it's still, instead of being n cubed, it's still treated as n squared, despite the lookups. Because I'm thinking that maybe this is specific to how it's implemented in Python and in other languages. You shouldn't necessarily have to, do a big O of n operation to get some substring. Or I guess even in, yeah, you should be able to append and remove items in order to get a string, right? Is what I'm thinking in other languages.
Is this part that you are concerned about?
Yeah, that ends up being a big O of S or N operation. So
Right.
we're doing, performing, big O of N squared for loops. But because we're doing this thing where we're just subscripting, that ends up being an additional cost.
But so I guess it is an additional cost. It depends on the size of the string that you're trying to match. We can assume that the string is trivial with regard compared to the dictionary that you're trying to look into. So effectively, that should be more like a constant time, right?
Right. Okay, sure.
And
If the yeah, I guess I'd leave it at the n squared then, and then the space complexity for this ends up just being big O of n space complexity, where n is the length of the input array or input string.
yeah, great. Um, so I guess the follow-up question to this would be, what if we made this a bit more interesting and we need to actually return the script?
And you need to actually return all of the strings.
Well,
So instead of returning true or false, you would return both book and Facebook. So let's say like a previous example where it's just Facebook and then face. In that case, you're saying it would be Facebook, like that.
right, exactly.
I see. Um, right. So I want to say that this problem I had as part of a homework for my algorithms problem, from my algorithms class recently. So this one's also really familiar. Haven't done it for an interview ever, but this was part of my assignment set for something we had to hand in. Uh,
So do you feel comfortable going through this now, or would you have a
yeah.
work in a different format?
So I guess I'd prefer another one because I can kind of reason how to do this one recursively. I remember that you're supposed to say use like a cache, or you're supposed to memorize to remember what all of the possible solutions are at each of the indices. And then basically what you would have to do is go through, say like picking at each index, can you add some tail that also is, inside of, or you'd pick a string from I to J and you would see if that's a word. If it is, you add that along with some tail value or some head value, depending on which way you traverse. and include that in
Right.
your result set. I don't know if that made
So
sense.
I think I have a sense of where we're going, but would you be comfortable writing uh the pseudocode for that?
Yeah. So I guess if we were leaving it pseudocode, I would pretty much have, say, some solutions, which is going to end up equaling, a list uh, for each of the indices. Say it's what is it? Yeah, list for the indices in range n plus 1, or it's n. I may have that off by 1, and then you can say that the solutions of n plus 1 is just equal to a list of a single string, which is just the empty string. And then let's say you had def solve on ind. We want to do solve to 0 to find all of the solutions that you get up to point 0. And then oh, I should change this around. This is supposed to be a map. Whoops. If, ind not in solutions, then you would go through to solve, and otherwise you return solutions of ind, which point you say that solutions of ind is equal to a long, it's a pretty long list comprehension, where it's something like S from I to J plus tail and tail, something like that. If S of I to J in word dict for J in range, ln of so this is like definitely pretty wrong code, but it's around generally this idea. Is this right? I remember the list comprehension was 2 nested for loops. You have a J, as well as I think maybe something like for tail in solutions of J, something like that. I may have the order completely reversed. Does this kind of make sense? Hello?
Yeah, sorry, I was on mute. I think you're on the right track. You're trying to kind of keep track of the characters in the world, I believe, at each position. So can you walk through this, on the simple example that you gave? And I think right now I'm seeing a little bit of, I think, an issue here. So if you can try to solve this by hand, that might be a good way to debug that.
Yeah, so this code is definitely wrong at this point. In the case that I didn't really pay attention to the order. This might actually be the opposite way around, where instead I'm doing solve of n minus 1 or something. But the basic idea was supposed to be that for each of the indexes, starting from the very last index, what you would want to do is determine all of the possible tails that you can have from that index, right?
Right.
And then when you go to, when you try to construct a string from before that position, you say, okay, let's see if this string plus this tail works out for all tails. So you're just, you have your entire, solution set to some point, or after some point. And then you're just fitting new words onto all possible solution sets, so that when you return solution 0, you're supposed to just return every valid separation that works from index 0 and onward.
Right. So I think that's the gist of it. But how do you actually make sure at each position that you can get a list of, of something that match?
Sure. So I guess so you want to convert this into like actual running code, right?
Yeah, or as close to it as you can get. At least I want to make sure that you write code that is like is complete, right? Because right now we don't
It's
know
just
how
like
we are getting
wrong.
the list.
Yeah. So let's think about this. I guess for correctness sake. Basically, all I'm saying is I have. Oh, I didn't take out the entire set of code. I should just copy the entire thing. Yeah. Say we have def break. Oh, word split on s and word dict. Um, and we len of s, and then our initial solutions is just empty. We say that n plus 1 is equal to the empty array. So is that true? One, there's a bug here in that it's supposed to be, I think, a nested value. Because each of the solutions is supposed to be a list of list values, right? Oh, that's not true. It's just a list of strings. So the initial value like this was correct. And what does it mean when we say that solutions of n plus 1 is equal to just the empty string? Or is it solutions of n? It should be n, because then we're saying that starting from, let's say with Facebook, starting from position 8, the only possible string you can make there is just an empty string, because there's nothing there, right? Going from 8 to 8. Yeah, that's just an empty string. I mean, it's out of bounds really, but cool. So we want to try and figure out what the possible splits are starting from position 0. That's why we call solve of 0. And we go through and see the end is not in solutions. So we say that we're going to have s from I to j for each of the j's. So this is supposed to call solve somewhere. That was part of the calls that were missing. So instead of solutions j, it's supposed to be solve inside of j is one thing, I think. So the very first time, I think, do I have to reverse the for and if here? No, I don't think so. Very first time we'll just have s of I to s of I to 1, which doesn't work out. Then I'll have s of I to 2, which doesn't work out. S of I to 3, which doesn't work out. None of these are going to end up making more recursive calls is part of the problem until I get to j ends up being, what is it, 7? Because at that point, I should end up having that I think this is an off by 1, just because the j is going to be exclusive here. So I think I have to end up writing n plus 1 here. So that the j becomes 8, and then s of 0 to 8 is all of, the entire string Facebook, right? But there's no tail when I call solve at 8, or at least it's just an empty string. So that seems like it ends instantly, and I'm only getting one string, but that wasn't necessarily true because earlier on I'm going to look for the word face, and I see that s of I to 5 is in word dict. So now I will call tail on 5. So that was my first recursive call, actually, in that I should at 5 for j equals 5, I'll call solve. and now I have solve is going to end up looking for strings starting from position 5, ending at n, and that using the same logic should find me s of 5 to 8, which gives me book. Is that correct? Yeah.
So I guess
book with an empty tail.
So I guess one way to put this, what are you doing here? Because if you think about what you're trying to do exactly, it might help you. What kind of search is this?
What kind of search?
So your search, yeah, like by calling this recursively, are you doing like, yeah, it's basically searching for the substrings, right? Like, I think it might help you to think about it in terms of you're doing the depth first search.
Yeah, I think it's probably closer to a DFS, right? If anything, because it goes all the way down to the deepest levels and then kind of backtracks.
Correct. Yes.
So to me, it seems like it's kind of okay. Reasoning through the boundaries that I have. The one thing though that might be wrong is the plus on the tail. I don't know if that. Yeah. There is an error here. So I'm not adding any spaces. I think I can do tail and.
What is tail? I think I'm gonna do the first question here, right?
Oh, so tail is pretty much the entire list of strings that are split after some position.
Can you?
So it's the entire set of strings. Sorry?
I mean, I don't see that variable initialized at that point. So if you call that, I don't like an issue.
It's on line 84. So this is an entire large list comprehension.
I
so tail will be initialized. Yeah.
Cool.
Is it okay if I try and run this on an actual example just to see where potential bugs are?
Sure.
Okay, so print word split, Facebook, and then, or I guess I can just copy this over. Oh, we changed it. Followed by Facebook. This is invalid syntax. Oh. So it may be the other way around. I always forget that I think the for has to come first, then the if. I is not defined. I can just call it I here. Cool. So that actually worked out, yeah, on the first example. One thing that we'd probably want to change around to expand on our test cases is what if we separate, book, right, into two multiple words? That should become part of our solution. Yeah, so this also seems to work out. I don't think we had any constraints set for non-empty strings, did we?
I don't know. I think we can assume that we don't need to worry about that.
About non-empty strings. Okay, sure. So the repeats, thinking of test cases, it seems like one split is okay, 0 splits is okay, multi-n splits. One thing that might be helpful to check is if I were to just have a single letter, maybe just to check for potential boundary cases. There's two versions of that. One is I just have the same letter repeating over and over again. And then the other one should be that I just have the item repeating once. So this one doesn't seem to work out, where I split a multiple. Oh, that's because I have a typo. Okay, so it does seem to work out, and it gives me 1, 2, 3, 4, 5, 6, 7 A's. That does match up with what I have. So I'd want to check as well if it just works with a single A. Cool. And an improvement would probably be if I can't do any splits at all. So let's say I have BCBP, or better yet, I just use my previous word dict and call it zebra and see how that splits. And we got an empty list, which is correct. As soon as we add, like, say, OK at the end, that should still be incorrect, or that should still be an empty list. Cool. So I think that ends up being my biggest set of test cases, and I will leave that as my solution.
Yeah, I think this should work. Yeah, this is great. And the complexity of the time complexity would be?
Yeah, this is pretty huge. Let's think about this. Just because I am doing a backtrack for every single index, right? Let's think about it. So if I want to get the solutions at index 0, I end up first going through all of the indices at least once, and then from each of the indices I end up going to every further index. So that in itself is n squared, but the list comprehension step itself is going to take quite a bit of time. It's not constant, right? But I don't know how to model the tail step as part of the input. Like it's dependent on the word dictionary, is what it seems like. So let's say that D is the maximum number of tails we get from splitting, in which case our runtime complexity is D times n squared. Yeah. As an optimization, one of the things I could do is actually check what the longest length word inside of my dictionary is, and say that the maximum range that I can have for J is actually not going to be I to n plus 1, but it's going to be based on the maximum length. Even though complexity-wise that's the same thing, I think in practice that's going to end up having pretty significant speed improvements.
Why do you think that?
Because when we think of really long, giant, let's say this just repeats and it's 20,000 characters, right? But let's say that the longest word is say 16 characters. In that case, instead of iterating through all the way to j equals 20,000, you're only going to iterate to j equals I plus 16, right?
Right.
So if I were to have inland is equal to max of word, ln of word per word and then use that in my for loop for j.
Then basically you don't have to iterate for the whole thing, and you can just assume the max length.
Yeah, it should be say
that length then, right?
Sorry?
You have to pre-compute that length, mean length, effectively before you start. So you're paying that cost. Would that still be worth it?
I guess it depends, right? So if it turns out that your it depends on which one is significantly larger. So if your string S is the size of it is significantly longer than the number of entries that you have inside of WordDict, then possibly it's worth it. If both of them are small, it doesn't really matter because it'll be fast no matter what. If it turns
Right.
out that your S is pretty small and your word dict is giant, then in that case, it's not worth it, right? So uh,
Yeah.
one thing you could do is have a check if you really wanted to optimize this and see which one of them is long, the len of word dict or S by some constant factor, if you care to. That operation itself will be constant time, right? So um, yeah.
Cool. Okay. So let's assume that somehow that's constant. It's a small string. You don't have to worry about that. So what is the complexity then?
If uh, for what? If we have a small string?
Yeah. And you don't have to
Oh,
worry about the main
the
length
longest word part.
of
Right.
yeah.
Uh, yeah. So I think for that it ends up being what we had before, where it's d times n squared.
Great. Um, and the space complexity.
Uh, yeah. I guess that ends up being n times d, right? Just because at max you're storing this d number at each of the indices, and there's n such indices.
Cool. All right. I think we are almost at the end of the hour. We can do another example if you want to I guess maybe use this time to do different type of questions. Uh, I've kind of been through the interview loop recently at companies in the Bay Area. So if you have questions around that, I'm also happy to answer that.
Sure.
I guess maybe one way to start is what are you measuring in right now?
Computer science.
Okay, computer science directly. And when are you looking to find a new job? Are you interviewing right now or just getting
Yeah,
started?
I'm interviewing at a couple of places, and for me, I'm actually finishing classes, you know, January, mainly
Okay,
starting in like April. Yeah.
cool. What kind of, I guess, feel free to let me know if you're not comfortable answering this, but what domain or area are you interested in finding a new job? Yeah, is it mobile? Is it backend, full stack?
Yeah, I would say it's mainly back-end work usually. Um, that's probably, yeah, I guess strengths plus interests are there.
Gotcha. And would you be interested in joining, like, do you have any companies in mind that you would be interested in joining specifically? Maybe I can help with that.
Uh, so um, one thing is maybe I think we could probably talk about this after the recording. Because for what I get, everything inside of these chats are supposed to be kind of anonymous, right?
Right.
Just because
Yeah.
they are
Yeah.
recorded.
And, feel free to not use anything that can, identify you. We can talk about names of company themselves, but if you're comfortable doing that after this, that's also fine. Basically, this is this is really great. Yeah, I'm very impressed, and I'd love to have you on my team. So yeah, let's try to connect after this chat.
Sure. I guess thank you for your time. This was it's the first question was actually pretty good. I'm pretty sure I did it before, like I mentioned, but it's still unfamiliar enough that you have to reason through it.
Yeah, and thanks for working for the second part of the program. It's a bit more challenging, but I think it definitely helps. Hammer in some concepts. So yeah, cool. Thanks for your time as well, and good luck.
Yeah, thanks and have a good day. And we can chat after.
Sounds great.